So we are trying to explore the data using graphs and table. In this section, we're going to talk about the histogram to plot the graph. In previous section, we discussed about the frequency distribution, where we use frequency with the different class interval. But here in the histogram, it's a frequency with the same class interval. So a graph consists of bars of equal width drawn adjacent to each other. Unless there are gaps in the data, if there is a gap, then you always see the gap. The horizontal scale represents a class of quantitative data values, and the vertical scale represents the frequency. So some of the things visually, histograms are very attractive. Visually display the shape of the distribution of the data, how the data is distributed. That's what we can see visually, and it shows us the center and how the data is spread, and if there is any outliers we can identify by using the histogram. For example, here is a it's a relative frequency histogram, and then relative frequency histogram. The difference between them is, as you can see here are the bars with the fixed number commute time, the same bar with the fixed number commute time. Sometimes we can use the frequency, sometimes we can use the relative frequency, which means percentage. While critically thinking about the data and interpreting the histogram, there are a couple of things we have to understand, or we can find the information from histogram. And they are the center of the data, the variation, the distribution, the outlier, and then time, sometime, which is also called CV dot. Okay, CV dot. Okay, so these are the common shape when we plot the graph of the histogram. So the first one is it's called normal distribution, which is also the bell shaped. And this is the uniform distribution. Everything, all the bar are the frequency is almost same. And this one, the third one, is it's skewed to the right. That means there is more tail. The length of the tail on the right side is more. And then fourth one is the length of the tail on the left side is more. So that's called skewed to the left. So commonly we expect the bell shaped for the normal distribution. So histogram is roughly bell shaped, and that's called normal distribution. Skewness, distribution of data is skewed if it is not symmetric like this, but it extends more to the one side, and you might have a positively skewed data like this, which is skewed to the right, meaning have a longer tail. Or you might have longer tail to the left. This is to the left, and before it was to the right. This one is the right, to the right. Okay. While accessing normality with the normal quantile plots, quantile means when you divide the data into 4 different groups, like first 25%, from 25 to 50%, 50 to 75%, 75 to 100%. So that's called quantile. So when we try to access normality, the criteria should be, for the normal distribution, the pattern of the points in the normal quantile plot is reasonably close to a straight line, and the points do not show some systematic pattern that is not a straight line pattern. And for not a normal distribution, the points do not lie reasonably close to the straight line pattern, and the points show some systematic pattern that is not a straight line pattern. So that's called not a normal distribution. This is one of the normal distribution pattern. Like you can see that most of the data, it's more close to a straight line, but this one is not a not a normal distribution, because most of the data, it's not close to the straight line. There is a proper way for finding either the data represents normal distribution or not, but we're going to discuss that in future section. Okay, let's try to look at some examples from this section. Heights of adult males are normally distributed. If a large sample of heights of adult male is randomly selected and the heights are illustrated in a histogram, what is the shape of the histogram? If it's normally distributed, the shape should be always bell-shaped. If you remember the shape I was showing you for the normal distribution, it should be bell-shaped. Okay, this is called normal distribution, which is always bell-shaped. So the answer should be bell-shaped. Let's go to next problem. Let's choose number 5. Here is the data, accompanying data with the frequency distribution are 45 commute times to work, and based on this data there are different options of the histogram is given. We need to find out which one is the right option, and does it appear to be the graph of the data from a population with a normal distribution, and then based on the histogram we need to find out either that is normal distribution or not. Look at the value from 0 to 14, 15 to 29. So this is the interval, class interval. If you look at the different class interval, as you can see that for the D, the class interval is 0 to 10, 10 to 20. So D is not the right answer. So among A, B, and C, one of them is the right answer. So let's look at the frequency here. As you can see that from 0 to 15, the frequency is 5. From 75 to 90, the frequency is 1. So as you can see here for C part, C from 75 to 90, the frequency is more than 1. So C is not the right answer. So the only option now we have left over is A or B. So now we're going to check more for the frequency. From 0 to 14 it's 5, from 15 to 29 it's 16, but if you look at A, from 0 to 15 and 15 to 30 they are same, so this is not the right one. So this is the right answer. Okay, and now based on this, as you can see here, if I try to draw this is if I try to draw bell shape like this, it's going to give me a increase and then longer tail to the right. So the histogram is has a longer right tail, so the distribution of the data is skewed to the right, and then histogram does not appear to be the graph of the data from a population with a normal distribution, because if it would be data from the normal distribution, then it should be normal distribution like this. Okay, let's pick another question. Let's question number 10. We have given the last digit of the heights of 62 statistics students were obtained as a part of an experiment conducted for a class. So this is the last digit for height. For example, let's say 60 inch, then 0 goes here. 63 inch, then that 3 goes here, and that's how you collect this frequency. Maybe 73 or 83 inches, something like that, and then that frequency goes here. That's how they collected the data. Now use the following frequency distribution to construct a histogram. So now you have to choose for the 0, last digit, the frequency is 15, and for the 1 the frequency is 4, for the 5 the frequency is 14. So 15, 4, 3, 5, 3, 14. So you have to match this information here. And as I can see, for 0 and 15, 0 and 5, the frequencies are higher, 15 and 14, 15 and 14, 15 and 14. So this does not look right. The B does not look right. Now let's ignore the B and let's check with the A. A has, for 6, 7, 8, and 9, all of them have the same answer, but that's not the case here. 6, 7, 8, and 9 has a different answer. So A is not the answer. B is not the answer. Now we need to choose from C to D. For the D, as you can see here, for the 0, the frequency is 15, but here it's almost 30. So C is the right answer. Okay, to answer the second part, if you look at the second part, are the data reported or measured? Measure means actual measure. When you try to measure the data height, the actual data should be something, not exactly the last digit, should not be exactly the whole number. It could be like 63.5 inch or something like that. So it does not appear to be measure. It looks like reported. Reported means you ask someone what is your height, and they would say, hey, my height is 73 inch or 62 inch, almost approximate. they don't tell you exactly like 62.3 or 69.05. So that's called reported. So the data appears to be reported. The data appears to be reported. Shortened heights occur are disproportionate number of times. So as you can see that like 15 and 14, they appear quite often because it's easier for if somebody asks you your height, then it's easier to round up to the like nearest tenth or in the fifth. So this is the right option. Okay, so I think these questions are fill in the blanks question. So it's just and our distribution has a bell shape. What type of distribution has a bell shape? Normal distribution for sure. So a normal distribution has a bell shape. So this is histogram.